I welcome you all to today's study. Today we are going to study refraction through a triangular glass prism. Refraction through a triangular glass prism. If we have an equilateral triangular glass prism, and we release incident ray on one surface of it, the ray on passing from air to glass, instead of going straight, it will deviate to change direction inside the glass. And on emerging here, it will bend. If this is the normal, if this is the normal, and this one too, the second normal, number 1, number 2. So refraction has taken place here, because refraction, as we know, is a change in speed and direction of light wave on crossing the boundary between two media of different densities. So this ray here is called incident ray. The one that bends inside this glass is refracted ray. Refracted ray. While the one that emerges here is called emergent ray. Now, this ray supposed to go, the incident ray is supposed to go straight, if not that it has been obstructed by a denser medium, which is the glass prism. And if we extend this emergent ray backward, it will meet the incident ray at this point, forming an angle here known as D. An angle D is called angle of deviation. Angle of deviation, which is D. Angle of deviation is defined as the angle formed between incident ray and emergent ray. So this angle here between incident ray and the normal is angle of incidence I. Angle of incidence I. This other angle here is angle of refraction R. Angle between this emergent ray and the normal is known as angle of emergence E. Angle of emergence. This I is angle of incidence. So, at a particular angle of incidence, it will produce a particular angle of deviation and angle of emergence. So, if we keep varying angle of incidence, angle of deviation and angle of emergence will be changing. So, certain factors affect angle of deviation. So factors that affect angle of deviation, factors that affect angle of deviation are: 1, angle of incidence. Angle of incidence I. Because as we are changing the size of angle of incidence, angle of deviation will also be changing. Another factor that affects it is refracting angle here, A. Refracting angle, A. For this equilateral triangular glass prism, all the angles here are equal, 60 degrees here, 60, 60, 60. There are other angles that are not equilateral. The angle here may not be exactly 60. Some can be more than that or less. So this refracting angle also affects the amount of deviation, the angle of deviation. The third factor that affects angle of deviation is refractive index of the material of the prism. Refractive index. Refractive index N. Of course, refractive index is the ratio of sine of angle of incidence to sine of angle of refraction. But for this particular prism, we can also get refractive index. We can calculate it using this formula. N is equal to sine in bracket A plus dm all over 2 all over sine A over 2, where A is the refracting angle. dm is known as angle of minimum deviation. The same A is here, refracting angle. And so this angle of minimum deviation can be obtained experimentally by varying the size of angle of incidence that will produce a corresponding angle of deviation and angle of emergence. So if we plot a graph of angle of deviation, if we have different values of d in degree against I in degree, and this is the origin, plotting d against I, it will be a curve. To give us this kind of curve. And this very point, when traced to this point, the angle here is dm. And this other angle here, this position is I. The corresponding value of I will be equivalent to E. So dm is the angle of minimum deviation, which is the least angle we can obtain here from this graph. And so when we get that value, assuming dm is 30 degrees, we substitute 30 here, and since A is 60, refracting angle, if it is equilateral triangular glass prism, 60 here and dm here, we solve it. Whatever value we have, give us the refractive index of this glass.